Okay, so this is page 250 or B250 in the Braille copy. And what we were doing was the square root of 16 p to the 8th q to the 7th. Okay. Do you need a different volume, Anastasia? So if you remember, volume 19.
Right.
Okay, so we look at the square root of 16 p to the 8th q to the 7th. We can also look at it as square root of 16 times square root of p to the 8th times square root of q to the 7th. And when we went through, we took the square root of each piece. So square root of 16 is 4 times square root of p to the 8th, we said was p to the 4th. And square root of q to the 7, since it's not an even number, what we end up with is q to the 3rd, because we can take pairs of 2 out. We can take 3 pairs of q out, which gives us 3, and we're left with square root of q because we have 1 left over. So we end up with 4 p to the 4th q to the 3rd square root of q. But there's one thing we have to make sure of. This q to the 3rd, since it has an odd exponent, that needs to be an absolute value because we want the principal root of it. So our final answer is 4p to the 4th, absolute value, q to the 3rd, close absolute value, square root of q. So basically, bottom line is you take the square root of each piece, and if your exponent after you take the square root is an odd number on a variable, you have to put those crazy absolute value signs around them. All right. So I'm just going to go through this quickly because I want to get through everything by the end of class. Okay, and now let's look at page 251, example 2, simplifying a quotient. Okay, so what we have is, example A says, the square root of open fraction x to the 4th over y to the 5th, and we want to simplify that. Okay, so first thing we do is look at it. We kind of pull it apart. So what we have is a fraction, numerator, square root of x to the 4th over square root of y to the 5th. We'll do each piece individually. So let's do the numerator first. What is the square root of x to the 4th?
X to the 2nd.
Yes, so our numerator is x to the 2nd power. Okay, so what about this denominator? What can we pull out and what's left in the radical? We have y, square root of y to the 5th. What can we pull out?
So we have to pull out in like pairs, you said, like, so you have to do like y to the 2nd times.
Yep. We have 1 left over inside, right?
That's y.
Square root of y.
That's square root of 1? Is
Yeah.
there an absolute value in there somewhere?
No, not in this one. Not in this one. But the rule here is we have still, if we have a denominator of Brian, you want to scroll down a little bit. There's more underneath.
I can go.
Oh, okay, then let me roll it up a little bit.
Okay.
See if that helps.
I wrote
So we have a numerator x squared over y to the second times square root of y. And what's the rule about having a radical in the denominator? Allowed or not allowed?
No.
Not allowed. So how do we get rid of the square root in the denominator?
You square each numerator and the denominator.
You can, but it's going to get messy. But what if we multiply the numerator and the denominator by square root of y? Would that get rid of that square root sign in the denominator?
Yeah. Do what?
You multiply the numerator and the denominator by a square root of y. Remember, we call that rationalizing the denominator.
That's right.
So what we do is we have a numerator now of x to the second times the square root of y over y to the second times square root of y times square root of y.
Wait, can you repeat that?
Absolutely. Numerator, x squared times square root of y over y squared times the square root of y times the square root of y.
Which just cancels out.
Right, and so what are you left with? In your
X squared times square root of y over y to the second.
But they don't cancel out. The radicals cancel out. So you have square root of y times square root of y.
Yeah.
Which gives you square root of y squared. So if you have y squared times the square root of y squared, what are you left with in the end? Brian, you want to scroll up. What I did was I actually started in the middle of the page.
Yeah, that's it.
So our numerator is x squared times square root of y, and our denominator.
Y.
And so you end up with y squared times y, right? Or y to the third. Because you have y squared times y to the first, you add your exponents and you get y to the third power.
Oh, I see. Because you end up with y after you multiply the radical, and then you end up multiplying the y to the second that's already there times that y.
Exactly. Okay, Brian, you see where I am? Above the squiggly line.
Oh, okay.
I'll be better about that. I'm sorry about that. Okay,
Okay.
so now let's look at another one. Now this one what we have is the fifth root. Okay, fifth root, open fraction, 5 over 4a. Okay.
What is it? 5 /
So numerator is 5, denominator is 4a.
Yeah.
Okay, so this is a fifth root. So first thing we want to do is look at it in two pieces. So the numerator is going to be the fifth root of 5 over the fifth root of 4a. So we need to ask ourselves, what do we need to do to rationalize the denominator to get rid of the denominator? Because there is no fifth roots in here. So what do we need to multiply 4a by to get the integer to be a fifth root, a perfect fifth root, and our variable to be a perfect fifth root? So what do you guys think? What is the smallest number that 4 goes into that is an equal fifth root, or a perfect fifth root?
20. So you multiply.
Is 20 a fifth root? So what number multiplied 5 times together gives you
5?
But it's not 5 times 4. It's something times something times something times something times something. I think that's 5. Times something. So let's think about what numbers. So let's start with 2. 2 to the fifth root is what? Okay. So what is 2 to the fifth? Sorry, 2 to the fifth power.
Yeah, okay, that makes sense.
And I just went, wait a minute. So my brain said something, my mouth said another.
I was like, wait.
So what is 2 to the fifth power? 32. Okay. So does 4 go into 32? Yeah. Okay. So let's look at this denominator. So we have 4a. We want to multiply it. Okay. Time for a fifth root of 4 times what equals 32? Does that one work? 8. Right. Okay. So we have our fifth root of 4a times the fifth root of 8. And then what do we need to multiply this a by to get it to a fifth root, which is a to the fifth? We already have 1a there. How many more do we need?
4.
4. So, Anastasia, that would be a to the what?
A to the 4th.
Yeah, exactly. So now we have the fifth root of 4a times the fifth root of 8a to the 4th. Okay, so we need to multiply our numerator and our denominator by this number, fifth root of...
Hold on. I lost you.
All right.
Fifth root of. So we have the 8, which we're multiplying by the denominator, right?
The 4a?
Yeah.
Yeah.
So we have fifth root of 5 over 32a.
Okay, and we need to multiply that fifth root of a to the 4th to our numerator, too. Because whatever we do to the denominator, we have to do the numerator as well. So what it should look like is, you have...
Where are you getting this? What?
Okay, so let me explain. So we have a numerator of fifth root of 5 times fifth root of 8a to the 4th over
8.
okay,
Fifth root of 5.
yep, times fifth root of 8a to the 4th all of that over fifth root of 4a times fifth root of 8a to the 4th. Okay, so that's what we're multiplying our numerator and denominator by. So let's start with the numerator. Let's multiply that, and what do we get? We get what's that? Oh, Lily, you're fine. Okay, so our numerator becomes 5, our fifth root of 5 times fifth root of a to the 4th, which gives us fifth root of 40 a to the 4th, right? When we do the multiplication. And then the denominator, we get fifth root of 4 times 8, which is 32. And then we have a times a to the 4th, which gives us a to the 5, fifth power. Okay, so now we need to look at this. we can take the fifth root of this denominator completely, which will get rid of any radicals in the denominator. But the numerator is not going to change. So our numerator is still fifth root of 40a to the fourth over, so take the fifth root of 32, which is 2. Fifth root of a to the fifth is just a. So we end up with fifth root of 40a to the fourth over 2a. All right. So, and the whole point of doing this is you do not want radicals in your denominator. All right, so I'm going to pause for a moment. Okay, and remember, this is an open note test. So you'll be able to take all this stuff into the test with you. All right, so now let's talk about multiplying radicals. So if we have something like 6 third root, so 6, if you're doing it in Nemeth, 6 GH3AR, 9n to the second.
Wait, what about a GR Nemeth?
Oh, remember, if you're doing it in Nemeth, if you're having a different root other than a square root, you do the GH, your root number, 3, 4, 5, whatever it is, and then your regular AR for the square root sign, and then your numbers, and then the terminator afterwards. Just a sec. I'm going to pause. Okay, so what we have is 6 third root of 9n squared, end radical, times
Third root of 9 what?
9n is in Nancy squared, times 3 third root of 24 n as in Nancy again. Okay, so basically what we need to do is the same thing. We need to just multiply through. So you have your 6 and your 3. You multiply those guys together. It's like apples to apples, oranges to oranges. So 6 times 3 is 18. And then we have our radical, because that's all we have outside of it. So then third root, 18, third root of 9 times 24. But I would say, instead of multiplying that through, let's break it apart, because we want to pull it apart and see as many third roots as we can get out of there. So we have 9n squared times 24n underneath. So what can we break those numbers down into? In terms of the basic factors of these numbers.
As far as taking third root?
As far as taking third roots, yeah. So,
well, you can't deny.
But let's break it down. So 9 we can say is 3 times 3.
Right, that would be squared.
Right, but now let's factor in that 24 part too. How can we break that 24? Is 3 a factor of 24?
Yeah.
So then that's 3 times what? 3 times what is
8.
3 times 8. All right, now let's look at our n's. We have times n times n times n. Okay. So, okay, yeah. So Brian, that's the multiplication symbol that you're pointing at right now. So we have 3 times 3 times 3 times 8 times n times n times n. So we have this 3 times 3 times 3. That's a group of 3 threes. So what can we pull out of that?
3.
3. Right. So now on the outside we have 18 times 3. And how about this 8? What can we pull out of this 8? Is that a perfect cube?
Yes. 2.
Right. Okay. So now we have 18 times 3 times 2 on the outside. And how about these 3 ends?
Yeah, you still have 10.
Times n. Right, exactly. And there's nothing left on the inside, is there?
No.
So the answer is 18 times 3 times 2. Which is what?
Times n.
What's that?
Times n.
Times n. Yes, times n. So what is 18 times 3 times 2? Somebody want to work that out?
108.
Yep, 108. 108n is our answer.
So you times that by 2. Or you can't like
No, it's just 18 times 3 times 2, which is 108. And then we have our n, so 108n, and that's our answer.
Okay.
And that's the end of the story. All right. Okay. So now what happens if we have binomials? So if we have open parentheses, 3 square root 5.
So it was open parentheses. 3.
Yep, 3 square root 5 minus 2 square root of 3, close parentheses, open parentheses, 2. Oops.
On your go kind of faster. Open parentheses. 3. Radical 5
Yep,
minus
2 rad 3.
2
Close parentheses.
that's the second root of 3.
Yep. Then close, then open.
You say times?
Yeah, close parentheses. So you should have open parentheses, 3 square root of 5 minus 2 square root of 3, close parentheses, open parentheses, 2 plus square root of 3, close parentheses. Okay, and this, if you notice, are 2 binomials. So
What's that
this
second binomial? I think?
second is 2 plus square root of 3. So what we need to do is FOIL it. So FOIL, front times front. 3 square root of 5 times 2. What would that give us?
6 square root of 5?
Yep, 6 square root of 5. Okay, outer. It's so hard for me to do the outer ones first, but we're going to do it. So outers are 3 square root 5 times square root of 3.
You add the square roots together?
Nope, we have to multiply them together.
Okay, so 2 square root of 15.
3, because we're doing the outer, so it's 3 radical 5 times radical 3. So 3 square root of 15. Our inner, negative 2 square root of 3 times 2.
What was that last one?
The outer one?
Yeah.
So that's 3 square root of 5 times the square root of 3 gives us 3 square root of 15. So you multiply what's underneath the radical and then the stuff that's outside of it. Okay, so then our inner is negative 2 square root 3 times 2. What would that give us? Negative 2 square root 3 times 2.
Negative 4.
Negative 4 square root 3. And last, but definitely not least, is our last. Negative 2 square root 3 times square root 3. What would that give us?
3 square root 9.
Say that again, Anastasia?
Negative 3 square root 9.
Right, and can you take that square root of 9?
Yeah, so negative 3.
3 times. Not, so it's negative 2, because we have negative 2 square root 3 times square root 3. So you have negative 2 times the square root of 9, which is 3. So negative 2 times 3, which is minus 6. So we have 6 square root of 5 plus 3 square root of 15 minus 4 square root 3 minus 6. Okay, and we can't do anything with that, so we just leave it as it is. All right. So that's it, foiling. Now, what's a conjugate? Conjugate are rationalizing your denominator. What numbers do you need to multiply the denominator to get any radicals gone? So if you have something like a numerator or a fraction of 1 minus square root of 3 over 5 plus the square root of 3. So basically we have a binomial on our denominator. And if you guys remember the difference of squares, we want it to multiply out so that we don't have any middle terms. And if we have 5 plus a square root of 3, what would we need to multiply our denominator by to get no square root of 3's inside of there, if it's difference of squares? See if you guys can remember that. Think in terms of FOIL. What if it's thinking about a perfect square? And if we changed a sign on our second term? Okay, I'm giving lots of hints here. What do you think? What if we were to multiply it by 5 minus the square root of 3? Can you guys hear me?
Pick the number.
Well, we'll think about it. So let's try multiplying it by the conjugate. Because remember, if we have 5 plus the square root of 3, the conjugate is 5 minus the square root of 3. So somebody FOIL that for me and tell me what you would get. And remember, what you do to the denominator, you have to do to the numerator as well.
Plus the square root of 3 over 5 plus the square root of 3.
So you have a numerator of 1 minus the square root of 3. So you need to multiply that by 5 minus the square root of 3. But first, let's look at the denominator. I just want to look at our denominator. So if we do the conjugate, so we have open 5 plus square root of 3 close. Open 5 minus square root of 3. What happens? What kind of number do we get? Can somebody FOIL this out for me? Front and front. We have 5 times 5.
25.
Right, okay, thank you. And what happens to our middle terms? We have square root of 3 times 5 and 5 times negative square root of 3? Do we keep middle terms or do they drop out?
They drop out.
They drop out. Right, because remember when you difference of squares, you end up with no middle term, which is what you want. And then the last term is square root of 3 times the negative square root of 3. And if
Negative 9 or
not negative 9.
X.
So square root of 3 times negative square root of 3 would give you negative square root 9.
Yeah.
And then you take the square of that and you get negative 3 or minus 3. So now our denominator is 25 minus 3, which is
42.
22. Okay, so the reason for the conjugate, if you remember correctly, is the reason for the conjugate is so that you get no radicals in your denominator because your middle terms drop out. And your last term, or if it's in your first term, if there's a radical in it, you end up with a perfect square and you can get rid of your radicals that way. But now we have to deal with this numerator. And if you remember, our numerator is, so Brian, you might want to scroll down.
Okay. So all you're doing is flipping the sign.
Yeah, exactly. You're just changing the sign on the second term. All right. So let's look at the numerator now. We have open 1 minus square root of 3, close, open 5 minus square root of 3, close. And so this will become our numerator. And it's our numerator over 22. So what do we get? What is our first term? 1 times 5. 5. Minus square root of 3 times 5 gives you minus 5 square root of 3. Last term is negative square root of 3 times negative square root of 3, which gives us a positive 3. Because negative times negative is a positive, radical square root of 3 times square root of 3 is square root of 9. Take the radical of that, and you get 3. Now we have to combine our like terms. So we have 5 minus 5 square root of 3 plus 3. So we combine the 5 and the 3, you get 8. So now we have 5 minus 5 radical 3 plus 3. So we combine our like terms, and we get a numerator of 8 minus 5 square root of 3 over 22. And that is your answer, just like that. That's all you can do, unless you wanted to use a calculator. But you can simplify it a little bit. But we're not going to worry. We're just going to leave it like that for right now. Okay, so that's using a conjugate. So now we're going to look at section 5-7.
Exponents.
Yeah, we're looking at rational exponents, page 257. So this is going from expressions from radical form into exponential form and vice versa. So we have a raised to the 1/4 power. How would you write that as a radical?
4th root of a.
Right, of a, because the power. Okay, Brian, I'm sorry I did it again. I'll scroll up to the top of the page. Okay, going up, going up, going up. Okay, yeah. So now what if you had a number like x raised to the 5/10?
Can you repeat that?
Mm-hmm. X to the power of 5/10, or 5 over 10. just for the sake of argument, I want you to just tell me what it would be in radical form.
Okay, so
This is more humor me.
okay, 10 power or 10th root of x to the second or fifth. So.
Yep, 10th root of x to the 5th. Exactly. All right.
5th root of x.
So you have 10th root of x raised to the 5th power. Okay. Now, what if you have something along these lines? If you have a fraction, so I can erase this. Okay. If you have a fraction, so open fraction, numerator, is 8th root of 81 over 6th root of 3. Let's simplify this first. First and foremost, let's put this, it's like, okay, how do we deal with this? Let's put this into exponential form. So we're going the other direction now. So what is the 8th root of 81 in exponential form?
81 to 1/8.
Everybody agree? Yes. 81 to the 1/8 power over, now we have 6th root of 3. Write that in exponential form.
3 to the 1/6.
Yep, exactly. Okay. Now, if you have numbers raised to a power in our numerator and our denominator, how do we deal with that guy? Okay. So, basically, what we need to do is simplify everything. And the rule is we have a base of 81 and a base of 3. Can we get these into the same base?
Yeah.
Is there a way? Yeah, because remember, if we are going to subtract or add our exponents, we have to have the same base. So obviously 3 we can't turn into anything else. But what about this 81?
27.
So do we want to turn it into a 3? We want that base to be a 3. So looking just at the 81, is there a number we can raise 3 to make it a base of 3, exponent of something that equals 81?
27. No, not 2 to the power.
Okay, so 3 to the what power?
9.
No, so it's 3 to the 9th power. Okay, so what is 3 to the 9th power?
81.
No, so it's 3 times 3 is 9, times 3 is 27, times 27 times 3 is 81, times...
No.
Okay, so it's 3 to the 4th. Everybody agree with that?
Yeah.
So what you'd write as your numerator then would be, open parentheses, 3 raised to the 4th power, close parentheses, raised to the 1/8 over 3 raised to the 1/6. And this is important because we have the same base. We have that 3 as our base. So now we can simplify this. Okay. First things first.
But don't you, what you do to the numerator, you have to do the denominator?
No. Because we didn't change it all. We just wrote it in a different formula or a different way. Because 3 to the 4th power raised to the 1/8 is the same thing as 81 raised to the 1/8. We didn't change it at all. We just changed the way it was written. Basically, it's the same thing as writing in grade 1 or grade 2 Braille. It means the same thing. Shorthand or longhand. But now let's look at our numerator, and this will help. So 3 to the 4th raised to the 1/8 power. We can simplify that. When we have something raised to a power, we multiply our exponents together. So what is 3 to the 4th raised to the 1/8 power when you multiply your exponents?
The 8th root of 81.
So you have 4 times 1/8. Because when you raise a power to a power, you multiply your exponents.
1/4.
So remember that 4 gets multiplied to the numerator, so you get 4 over 8. Which is the same thing as what?
1/2.
1/2.
2,
6.
So 3 to the 1/2 power over 3 to the 1/6 power.
6.
Everybody agree with that?
Mhm.
Okay. Everybody see how I got that, I guess is the real question. Okay, if somebody doesn't understand, ask the questions now.
What is the answer?
3 to the 1/2 over 3 to the 1/6. Okay. And now if you have a base to an exponent divided by a base to the exponent, how do you combine those?
Like multiplying?
Well, you're dividing. And when you're dividing what operation happens to your exponents?
Well,
You subtract them, because we're dividing, we're not multiplying. So if you're base and you subtract your exponents, so you get 3 to the 1/2 minus 1/6. Okay, so you have 3 raised to the 1/2 minus 1/6. And what does that give us? Remember, our base doesn't change. So what is 1/2 minus 1/6?
or 6, 2/3.
Not 2/3. You have your denominator correctly, that it's thirds. So you have to turn that 1/2 into 6. So you have to have the same denominator. So what is 1/2 in terms of 6? We'll say, Nathan, did you say 2/6 or 2/3?
I changed it to 2/3.
Okay, so 1/2 becomes 3/6. 3/6 minus 1/6 is 2/6. And then when we reduce 2/6, we get 1/3. So our answer is 3 to the 1/3. And can somebody write that in radical form for me?
3rd root of 3.
Yes, 3rd root of 3. Very good. Nice. This is section 5-8 on page 263. This is the radical equations. This is the last 2 sections. This is basically, if you remember how we're solving our radical equations to find a number, our answer to our variable, and then we have to throw it back in our original equation to see if it checks. Okay, so this is like the problem square root. X plus 1 end square root plus 2 equals 4. Again, that's square root of x plus 1 end square root plus 2 equals 4.
So subtract the 2.
Yep, exactly. So you're left with x plus 1 equals 2. And then what's our next step?
Then you have to take the square each side.
Yep,
X
square
plus
each
1
side.
equals 4.
X plus 1 equals 4.
And then x equals 3, subtract 1.
Yep, exactly. And so now we got to throw this guy back into our original equation. So what that looks like is the square root of x plus 3, 3 plus 1. Go ahead of myself. Let's see here. So we have 3 plus 1.
Which is 4, square root of that, 2, plus 2, 4.
Yeah, 2 plus 2 is 4. So yes, it checks. So it is a good answer. It's not extraneous. It's not an extraneous answer. All right. Okay, so now let's look at one that is an extraneous answer. So if we have something like square root x minus 15 equals 3 minus square root of x. All right, so this one we don't have things to kind of shuffle around. We need to square each side.
Is it radical? Is it square root of x closed radical minus?
It's open radical x minus 15 closed radical.
Okay.
Equals 3 minus open radical x closed. Okay, so we need to square each side of this one because there's nothing, we have radicals on both sides. So we just square them as it is. On the left, squaring x minus 15 gives us x minus 15, no radical. The right side, though, you have to use the FOIL method. So you square your first term, you have 3 times 3, which gives us 9. Our outer terms would be
Sorry about that. My phone is ringing.
That's right. Okay, then you have 3 times minus x. I mean, times 3 times negative square root x. You get minus 3 square root x. And again, you get minus 3 square root x. And then your last term is plus x because you have negative square root x times negative square root x gives us a positive x.
Okay, you lost me.
Okay.
9 something?
All right, so you get 9 minus 3 square root x and radical minus 3 square root x and radical plus x. And then we can combine those two middle terms because we have a square root x on both of them. So then you get x minus 15 equals 9 minus 6 square root x plus x.
How did you get that?
Since you have open 3 minus square root x closed squared, you have to FOIL that. You have to multiply 3 minus square root of x times 3 minus square root of x.
I have a question though.
Yeah.
Since you have 3 minus square root of x, can't you get rid of that 3, subtract it from the other side since there is no radical over there anyways, and then take the square each side?
No, because you do have a radical. The other side is a square root of x minus 15.
No, we just got rid of that, making it x
Right.
minus 15.
But you have to square both sides first before you can move on and move things around.
Oh, I see what you mean.
So that's why you have to FOIL it and get 9 minus 3 square root x minus 3 square root x plus
so equals 3 minus square root
Wait, no, so let me, what, so you should get 9 minus 6.
Oh, okay, I see. So 9 minus square root of x squared.
No, okay, okay. So let's back up a little bit. So you have 3 minus square root of x, close. Open, 3 minus square root of x, close. You have to FOIL it. So your front term is 3 times 3, 9. Your middle term is negative square root x times 3 minus 3 square root x. Outer term, 3 times minus square root x is again minus 3 square root x. And your last term is as square root of x squared, or just plain x. So plus x. And then you combine your middle terms. Because you have a minus 3 square root x and a minus 3 square root x, which gives us minus 6 square root x.
Still trying to figure out why that squaring both sides doesn't get rid of both the radicals.
Because that 3 is not under a radical. It's only 3 minus square root x. There's no, that 3 is not under a radical. Which is, that's why.
I see.
Okay, so now we have x minus 15 equals 9 minus 6 square root x plus x. And we just combine like terms and move things around. So we have this 9. And what do we want to do with our 9? We want to move it over to the left side. So we get x minus 24 equals negative 6 square root x plus x. And we can, plus x, and we can move that x over to the left and we get x minus x, so those drop out. And we get negative 24 equals negative 6 square root x, and basically we go through the process again. So we want to get this negative 6 apart from the square root x so we can deal with that. So then we have negative 24 divided by negative 6, which would give us 4 equals square root of x. Square both sides. 4 squared equals square root of x squared. 4 squared is 16. 16 equals x. Okay, but does it work? So then what we have to do is we said x equals 16. Put it back in your original equation. Square root of 16 minus 15. Does that equal 3 minus the square root of 16?
Yeah.
Okay, well now let's check. Let's see here. What is the square root of 16 minus 15? So that's the square root of 1 equals 3 minus the square root of 16 is 4. So square root of 1 is 1 equals 3 minus 4 is negative 1. So we have 1 equals negative 1. No, it does not check. So this problem has no solution. So it's a no solution answer. Okay, so right now we're going to stop here, and what I'm going to do is I am going to create one more video just to go over the last part of this section and then section 5-9. So, and I'm going to post it up on YouTube this after school today, and that way you guys can watch it if you need to study more for 5-9. And all of this today has been recorded as well.